erase this stuff and let's get ready for a test. So Celeste and I just had a little lesson in being a Boy Scout or a Girl Scout. And guess what it is? I'm starting to work on the board and there's no eraser in here. So how in the world can I teach without an eraser? So I can either go and take one from another classroom, which is what somebody did to us, or I can go to my Boy Scout closet and always be prepared. What do you think I have sitting in my closet?
An eraser?
An extra eraser, and extra markers, and extra everything. So I pull one out, and we're ready to go. On page 708, Chapter 10, Practice Test. A student wants to take two courses, A and B, which are both available at 9, 10, and 11 o'clock. Make a tree to show all the possibilities. Well, let's see. What is it? They can take course A at what time?
9, 10, and 11.
At 9, 10, or 11.
Yep.
And then they can take course B at what?
9, 10, and 11.
Now, if A is at 9, then B would be when? At 10 or 11, right? Because I couldn't take B at 9 o'clock because I'm taking A at 9 o'clock.
Oh. Yeah.
If I take A at 10 o'clock, then that means I would take B at what time?
9 or 11.
9 and 11. And if I take A at 11 o'clock, I'm going to take B at 9 or 10.
That's a weird tree diagram.
Does that make sense?
Yeah, it makes sense. I just don't remember doing this before. Maybe we didn't have it.
So do they want to know all the possible schedules?
What are we doing?
Page 708, problem 1,
Chapter 11, right?
chapter 10, page 708. Oh, they did it differently, didn't they? But is this like saying A9, A10, and A11?
Yeah.
That's what they have. They just labeled them differently. I just said A at 9, 10, and 11, and then B would be at 10 and 11 for not when that's at here.
Yeah.
So I still come up with how many possible schedules could I have? 1, 2, 3, 4, 5, 6. 6 possible schedules. Okay? Question 2. A restaurant offers a choice of 2 soups, 3 entrees, and 5 desserts. Now, I'm just going to go soups, 2, entrees, what? 3, and desserts, 5. Isn't that what they just told me they have? Did I copy that down right? 2 soups. How many different meals consisting of a soup, an entree, and a dessert are possible? Okay, so a meal would be order a soup, order an entree, order a dessert. How many choices for soup?
2.
2. How many choices for entrees? 3. How many choices for dessert? 5. So what's the answer?
30.
30 different meals could be ordered.
Mm-hmm.
Does that make sense?
Mm-hmm.
Number 3. 2 dice are drawn. How many different outcomes are possible? 2 dice. Well, how many possible here for the first dice?
6.
6. How many for the second dice?
6.
6. So how many possible outcomes?
42.
6 times 7 is 42.
36.
So 6 times 6 would be 36. 3B says, how many ways could you get a sum of 5? How do you get a sum of 5? I would get a, what? A 1 and a 4. Isn't that right? A 2 and a 3. I mean, let's just put them up here. 1, 2, 3, 4, 5, 6. I've got 6 numbers I could get. Agreed for the first dice?
Mm-hmm.
If I get a 1, I could get a 4. If I get a 2, I could get a 3. If I get a 3, I could get a 2. If I get a 4, I get a 1. And 5 and 6 aren't going to do anything for me, are they?
Mm-hmm.
So how many, now possible outcomes, (36), desired outcomes would be what? 4? So what are they asking? How many different ways could you get a sum of 5? And the answer would be 4. If we want to know the probability of getting a sum of 5, it would be 4 out of 36. But probability is the next chapter.
Mm-hmm.
But since you're doing both of them on the test, I kind of want you to think about, this isn't asking for probability, this is asking for how many.
Mm-hmm.
Number 4. 2 cards are drawn without replacement from a deck of 52 cards. So what do? I make 2 spaces. I have 52 cards here, right?
Mm-hmm.
Then when I draw 1, what do I have left?
51.
51 cards.
Mm-hmm.
Now, what am I looking for? A black jack and a red card. So how many ways could I get a black jack?
One.
How many?
I don't know how many black trucks there are. I
Oh,
think just one.
there's just one, isn't there?
Yeah.
A black jack and a red card. How many red cards are there?
26.
26. So that would be 1 times 26. Oh, black. No, blackjacks. There's the spade jack and the club jack.
Oh.
So that would be 2.
Right.
2 of those. Number 5, an airline has 3 flights from city A to city B. So here's city A, and there's 1, 2, 3 flights to city B.
Wait, Dr. Bono, how do you solve the last one?
Oh, this one? There's 2 choices here, 26 choices here.
Right.
So the total possibilities would be 2 times 26. 52.
And why did we write the top part?
Oh, this up here?
Yeah.
I was just looking at what they were telling me in the book. 52 cards, and I'm going to pick 2 of them. So that would be 52 and 51. But then they're saying, no, we don't want just any card. We want what?
The blackjack.
A blackjack, which there's 2 of those, and a red card, which there's 26 of those. If it just would have been
It's the first part.
how many possible outcomes for any card, it'd be 52 times 51. So what I did, just my standard technique when I see story problems, I take the information they give me and put it on the board. But then, okay, so now I've got the big picture up here. Now, what is it they want to know? They want to know about blackjack and red card.
Right.
So I don't use these numbers up here. Number 5, 3 flights from A to B and 5 flights from B to C. So from B to C, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2, 3, 4, 5. All of these go to C. So what do they want to know? How many ways can you fly from city A to city C? So how many ways can you get from here to here?
15.
5, 10, 15, right? Which is the same as 3 times 5. That sequential counting principle. Number 6, 7. What does that say? 7. And how do you calculate 7?
7 times 6 times 26.
That's why it has an exclamation mark. So you just get your calculator and punch in the numbers. And the only way you could miss it is if you just punched in the numbers wrong. What about 6B? 7, 4. That would be what? 7 times 6 times 5 times 4 over 4 times 3 times 2 times 1. So those all cancel, don't they? So this one is just going to be 5 times 7 times 6 times 5. 210. 30 times 7. All right. Number 7, 3 factorial times 4 factorial. Three factorial times 4 factorial. What's 3 factorial? What's 4 factorial? So that would be 6, right? And that would be 24. So what's 6 times 24? 144. Does that make sense? So what if it said 3 factorial plus 4 factorial? That would equal what, 30? See that? Number 8. P parentheses 5 comma 5. P parentheses 5 comma 5. What is that? 5 things taken how many? 5 at a time. Everybody see that?
Mm-hmm.
How many choices for the first one?
5.
5. For the second one? Once I've picked one, 4, 3, 2, 1. So that would be 20 times 3 is 60, 120. So what's number 9? 8 things. No, let's do 9B. 7 things taken 3 at a time. P7, comma 3. So that's 1, 2, 3. And how many for the first one? 7 times 6 times 5. So that would be 210 again. Now, I'm sorry, but if this is a, oh no, this is 210, that was 120. Being dyslexic with my numbers here, okay? In how many ways can 4 people be arranged in a row for a group picture? So I have 4 people and 4 chairs, right? Here are my 4 people. How many people for the first chair?
4,
How many for the second?
3,
For the third?
2,
And for the last?
1,
So how many possible ways could I seat these people?
40.
24? There are 24 different ways I could have 4 people seated for a picture. Does that seem like too big a number?
kind of.
So watch what the guy will do on the test. He'll say, what number seems more reasonable in your little heart? 12? So let's put down 12 as one of the choices. And while you're taking the test, you go, well, I got 24, but that 12 looks pretty good. So maybe I'll pick 12 as the correct answer and see what happens. And what will I do when you turn your test in?
Grade it wrong.
So just remember, you're going to get big numbers that sometimes your heart doesn't agree with. Skip 11 and 12 because they're not on the test. So we don't need to mess with them. How many counting numbers less than 50 are divisible by 2 or 5? How do you count things? One, 2, 3, 4, 5, 6, 7, 8, 9, 10, right?
Mm-hmm.
Up to, did it say what?
50.
250 or less than 50?
Less than 50.
So I go up to 49. Divisible by what? 2. What would that be? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48. Divisible by 5. What would that be? 5, 10, 15, 20, 25, 30, 35, 40, 45. Is that it?
Mm-hmm.
So, what do we have here? Did it say and or? And 5 or 5?
Or.
So I put or 5. So that means it could be all of these,
Mm-hmm.
which would be how many?
I don't know.
1, 2, 3, 4, 5, 6, 7, 8, 11, 12, 13, 14, 15, 16, 17, 18, 1, 2, 23, 24. Okay?
Mm-hmm.
Or it could be all of these. How many do I have here? 9. Are any of those duplicates? Yep. 10 and 10. 20 and 20. 30 and 30. And 40 and 40. How many duplicates do I have?
4.
So I go 24 plus 9 minus what?
4.
4. You follow that?
Mm-hmm.
Well, then let's do number 14. How many different sums of money can be made with a set of coins containing a penny, a nickel, a dime, a quarter? So now I have a penny, a nickel, a dime, and a quarter. And I want how many? 2 coins?
I think so, yeah.
Is that what it said?
Yeah.
Exactly 2 coins were selected. How many coins for the first one?
4.
4. How many for the second one?
3.
3. So, what would that be? Would that be 12?
Yeah.
But if I have a penny, a nickel, a dime, and a quarter, and I have oh, 4, 1, 2, no, only 3. And I have 3 choices for the next one. Penny would be what? Nickel, dime, and quarter? But then with the quarter, it would be a penny, a nickel, and a dime. Now what did they just ask there? How many different sums of money? So, sums of money would be like a committee. So instead of having a permutation of 4 things taken 2 at a time, it's a combination of 4 things taken 2 at a time. Because the penny and the nickel, that's what, 6 cents? That's 11 cents, and that's 26 cents. A quarter and a penny, that's 26 cents, isn't it? So see how that's the same as the penny and the quarter?
Mm-hmm.
So I end up, I end up with a bunch of duplicates. So what's going to happen? So that's going to be 4 times 3 divided by
2.
2
Exclamation
factorial.
point.
So that's going to end up being what? 6. So you have to keep straight whether it's order matters or order doesn't matter. Number 15. How many subsets of 3 elements does A, B, C, D, E, F have? So subsets would be what? Permutations or combinations?
Combination?
That's right. Sets are combinations. So a combination of how many things taken, what did they say?
There's 6 things. Taken 3 at a time.
How many subsets? Of 3. So 3 at a time, and how many did I start with?
6.
6? A, B, C, D, E, F. So that would be 6 times 5 times 4 divided by 3 factorial, which is 3 times 2 times 1. So 3 times 2 is 6. So the 6 and the 6 cancel out. So the answer would be 20. Does that work for you? Number 16. A combination of 5 things taken 2 at a time would be what? 5 times 4 divided by 2 factorial. A combination of 6 things taken 4 at a time would be 6 times, 1, 2, 3, 4, 5 times 4 times 3 divided by 4 factorial. 4 times 3 times 2 times 1. Well, the 4 and the 3 cancel. The 2, well, let's just leave that 2 there and say 30 divided by 2 would be 15. Does that look right? I don't know. Is that what the answer book says? You're not going to tell me. 16b, 15, 17. Oh, 17a. 6 things, a combination of 6 things taken 0 at a time. What would I have?
Would it just be 0?
Would it be 0 or would it be 1?
0.
What's the answer say?
What?
1. You go what? Yeah. If I have 6 things and I don't take any of them, then what do I have here on my table? 1 set with nothing on it.
Mm-hmm.
If I have 6 things and I don't put any of them in a box, I have an empty box. So I have 1. Better write yourself a note on that one, shouldn't you? Number 18. 2 cards are drawn without replacement from a deck of 52 cards. So here I am with 2 cards and 52 for the first one and 51 for the second one, right? See why I'm putting that up there, Carissa? Even if I'm not going to use it, I'm just looking at what they're telling me. Now, then I read what they say next. How many different sets of 2 cards are possible? Sets. When they say sets, then what does that make that? A combination of 52 things taken 2 at a time. Everybody see that?
Mm-hmm.
So that's going to be 52 times 51 divided by 2 factorial. So sets will be combinations. How many different orders could I have? 52 times 51. All right, that's the end of this part of the test. Let's turn over to chapter 11 on page 776. Whew. Boy, this test is going to be exhausting, isn't it? But we're only going down to problem 10. So relax. We'll just stop at problem 10. A single die is rolled. Find the probability. When they say probability, then that means I have 1 die, 6, 5, 4, 3, 2, 1. So I have how many possible outcomes? 6. And what's my desired outcome?
6.
of a number different from 7.
All of them are different.
So that would be 6 over 6.
Mm-hmm.
Then what's the second part? A number greater than 2. That would be from 2 on up. So out of the possible outcomes are 6. What's the desired outcome?
4.
4. Which reduces down to 2/3. And this reduces down to 1. Number 2. A box contains 5 balls numbered 1 through 5.
Mm-hmm.
So now I have 5, 4, 3, 2, 1. You see what I'm doing? I'm just putting those 5 balls up here. If a ball is taken at random from the box, so I'm only taking one of them out of the box. So what are the possible outcomes? 5. You follow that?
Mm-hmm.
So now what does it say though I'm wanting? An even numbered ball. Where would be even numbered? Even, even.
Mm-hmm.
So that would be 2 out of 5?
Mm-hmm.
So that's A. What's B? The ball number 2. That would be what?
1 out of 5.
1 out of 5. And what's C?
4 out of 5.
Not ball number 2. That would be
4 out of 5.
1, 3, 4, or 5. So that would be 4 out of 5.
Mm-hmm.
You follow that?
Yep.
Good. Number 3. A box has 2 red balls marked red 1 and red 2. So I have red 1 and red 2. And it has, where did it go? 3 white balls. White 1, white 2, and white 3. White 1, white 2, and white 3. Why'd you write them down twice? Well, what's it ask? 2 balls are drawn in succession and without replacement from the box. Find the number of elements in the sample space. Oh. So really what I have here is red 1, red 2,
Mm-hmm.
and white 1, white 2, white 3, don't I? Out of my one box. And I'm going to draw how many balls out of that box?
2.
Mm-hmm.
2. So how many choices for the first ball?
5.
1, 2, 3, 5. How many choices for the second ball?
4.
4. Is that what they want to know?
Mm-hmm.
Oh, 3B says, what if you put the ball back in after you draw one? And then draw another one. Then how many choices for the second ball?
5.
Yeah. So that would be 25, wouldn't it? If I replace it with replacement. Number 4.
Wait.
2 cards are drawn without replacement from a standard deck of cards, a 52. So without replacement means I would have 2 cards, 52 and then 51, right?
Mm-hmm.
For the second one. Now what are they asking? find the probability. So we're doing probability. So the possible outcomes would be what? 52 times 51. The desired outcome, what's the desired outcome? Both cards are red. So how many choices for the first one being red?
26.
26. And how many for the second one?
25.
So the desired outcome would be 26 times 25. Follow that?
Yeah.
Mm-hmm.
So 25, and no, that's not going to do anything. I'm just going to have to take my calculator and go 26 times 25 equals 650 over 52 times 51 equals 2,652. What's 650 divided by 2,652? 0.245 approximately. Or do they want me to leave it as a fraction? Which one is that? 4a? Oh, they leave it as a fraction, don't they? So I guess to reduce it down, that would be divide by 2, 325 over 1,326. Is that as far as I can go with it?
Mm-hmm.
That's it, huh? Number 4B, neither card is an ace. So now, I'll go the other direction here. Two cards, neither is an ace. So how many cards in the deck that are not aces?
48.
48. There's 4 aces, right? So that would be 48. And so if I get one that's not an ace, then how many left? 47. So that would be 48 times 47 over 52 times 51. Okay? So, number 5. One card is drawn from a standard deck of cards and then replaced. Then another card is drawn. So if I replaced it, that's going to be 52, and then what? 52 again. Do you see that?
Mm-hmm.
Because it can be replaced. So, what does it say now? Both cards are red. So I want a red card both times. So how many possibilities for a red card? 20 what? 6, right?
Mm-hmm.
Then if I put the red card back and shuffle them, how many possibilities for the red card the second time?
They're 26.
26.
See? Now, do you see how that's messing with you? You said, no, I've been going 26, 25. But this says, with replacement. That's important. So if it's replaced, so now it's going to be possible outcomes, 52 times 52. Desired outcomes, 26 times 26. What is 26? 1 and 2, is that right? And 1 and 2. So what would that be?
Just 1/2.
1 times 1 over 2 times 2?
Yeah.
1/4?
Well,
So watch out if they say, and then it's replaced. A fair coin is tossed 5 times. So now I've got a coin. 1, 2, 3, 4, 5 times.
Mhm.
Right? And how many possibilities for the first time?
5.
I toss a coin. What's it say?
2.
At least one head.
Mhm. There's 2 possibilities for all of them.
At least one head. So, because it's either heads or tails,
Mhm.
so there's 2, 2, 2, 2, 2.
Mhm.
Right? So how many possible outcomes? Four, 8, 16, 32. At least one head. So we could have one head or what?
Tail.
2 heads or what? 3 heads
Yeah.
or 4 heads. So if we want to make a picture of this, we would go head, tail, head, tail, head, tail, head, tail, head, tail, head, tail, head, tail. Head, tail, 1, 2, 3, 4. Oh my goodness.
Mhm.
Head, tail, head, tail, head, tail, head, tail, head, tail, head, tail, head, tail. One more.
What's a good zipper?
You don't like these pictures, do you, Carissa?
So I want what? At least one head.
Mhm.
Well, how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 50, 60, 70, 80, 90, 20, 21, 22, 23, 24, 25, 32. That's what we got, was 32, wasn't it?
Mhm.
If there's at least one head, when will you always have at least one head here? Every time except when you have all tails.
Yes.
So, at least one head would be anything except no heads, which would be all tails. So, if no heads would be 1 out of 32, at least one head would be what? 31 out of 32?
Mhm.
I know you don't like the pictures, Carissa, but Celeste does, don't you?
Yeah.
I mean, she likes them to see what's going on.
I just don't like making them.
Yeah. But do you see where, when you're trying to see what's going on here, that drawing a picture helps you see what's happening? And that helps you understand why, except no heads, that would be 1/32. So at least one head would be 31 out of 32.
Mhm.
Which one was that?
6.
Number 7. An urn contains 5 white, 3 black, and 2 red. 5 white. Can't believe I did all that work and then I had to erase it. 5 white, white 1, white 2, white 3, white 4, white 5, and what else? 3 black, black 1, black 2, black 3, and what else? 2 reds. Red 1 and red 2. And find the probability. So probability would be possible outcomes. What am I drawing here? In a single draw, in one draw, so I'm going to draw one time. How many possible outcomes?
10.
10. And what's my desired outcome?
8.
What?
8. And
What's it say?
white or black.
A white or a black. White or black would be all of those, wouldn't it? 8 out of 10. What's the next question? A ball that is not red.
Also
Not red would be
8 out of 10.
8 out of 10 again.
Saying the same thing.
I don't know why they did that. Number 8. 3 cards are drawn without replacement from a standard deck of cards. Without replacement. So I'm back to 52. Did it say 3?
Yep.
51 and then 50. What's the probability that they are all face cards? Jack, Queen, or King? So the possible outcomes would be what? 52 times 51 times 50. The desired outcomes would be 3 times 2 times 1. Agreed? Because there's 3 face cards? No, wait a minute.
No, there's not.
12.
There's 12.
There's 3 face cards of each kind. So that's of spades, of clubs, of jacks, of hearts, and of diamonds, right? So that would be what? 12? So I have 12 times 11 times 10. Over 12 times 11 times 10. All right. A student, number 9, estimates that the probability of passing a math or an English test is 0.9. Math or English? Math or English is 0.39. Is that what he said? No. Math or English is 0.9. What's he say next? Probability of passing English is 0.8. English is 0.8. But the probability of passing both is 0.6. Is that what he says? Okay, put this in your notes. The probability of A union B equals the probability of A plus the probability of B minus the probability of A intersect B. And A union B is OR, and A intersect B is both. Intersection is where they overlap. It has to be both of them. You got that? So now with that in mind, OR would be 0.9 equals, okay, we don't have
Wait, is this problem 9?
problem 9.
Oh, wouldn't you just make an algebra equation to figure it out?
Let's do this way and see what happens.
Okay.
So, and now it's E, so it's E and M, and E is 0.8, and I don't know M, and I subtract the intersection, which is both, 0.6. So 0.9 equals 0.8 plus something minus 0.6. 8 minus 0.6 is 0.2 plus something is 0.9 minus 0.2 minus 0.2. That would be 0.7 is the empty box, and that was M. So the probability of passing math is 0.7. Is that what they want to know? What's the probability of passing math?
Oh. Wait.
So, do you see?
Oh, I see. Okay.
OR is union. This is that equation that's in your book. But just write that down and then put union is OR, intersection is both, and then A and B just become whatever these numbers are. You say, well, what if you switched them? Well, it wouldn't matter, would it? If this was M and this was E, you would still have these numbers reversed, but you would still find the answer. So you take this formula, you take the numbers they give you and plug them into this formula. So you might want to make a copy of this little problem and bring it with you to the test. Number 10. 2 dice are rolled. Find the probability that the sum turning up is 11, given that the first die, so I have 2 dice here, and it's given that this one is a 5. Is that what they just told us? Is that what they just said for problem 10?
Yes.
So the first one is a 5, and the second one can be 6, 5, 4, 3, 2, 1. So I have 1 possibility here, because it's given, times 6 possibilities here. So the possible outcomes would be 6. Everybody follow that? 1 times 6. The desired outcome, what am I looking for?
The sum turning up as 11.
So I want 5 plus what? That would be 5 plus 6, wouldn't it? So that's only 1.
Yep.
So when they give you something, say, okay, this is given. So can you see where I could either have 5 with 6, 5 with 5, 5 with 4, 5 with 3, 5 with 2, 5 with 1. So that would be 6 possible outcomes. But the only one that produces 11 is this one. So that's 1, the desired, so the probability is 1 out of 6.
Okay.
And that's it.
Alright.
If you can do all this stuff we just did on the board, then you will be fine on the test. The thing is, here's what gets messy with the test. It's just like there's so much stuff. I mean, well, we did all that chapter 10, we come over here and do all this chapter 11. It's just by the time you get to the end, your brain's almost fried.
Yeah.
Yep.
So you go, I have to be extra careful when I get toward the end of the test. And when you're teaching your little chippers down the road someday, realize that they even have smaller capacities than you have to soak stuff up. So you'll find out and say, hey, how come all the children in my class missed the last 3 problems? What does that tell you? My test was probably too long. Because their little brains were fried. Well, didn't we have fun today?
Yeah, that's one mark for it.
But I get the impression from looking at the looks on your faces that you actually understand this stuff. I mean, you can see you're going to look at your notes as you look this over and say, I think I'm ready for this test. I think I can do this. Good. Well, have a nice day. And on Tuesday, we'll take an exam.